Hello, I hope you're doing well. Today I want to talk about minimizing the cost to run a pipe from a refinery to a storage tank. In this particular problem, there's a river that separates the refinery and the storage tank. So here's the setup of the problem. I have a refinery, I have a storage tank, and I want to run a pipe from the refinery to the storage tank. But it's a different cost to construct the pipe over the land compared to constructing the pipe in the water. And in fact, I have a 500,000 and 800,000 per kilometer cost. So to do this problem, I need to figure out the cost over the land and the cost over the water. Now to do that, the cost over the land is going to be equal to the length of the pipe over the land times the land cost. Because length is going to be measured in kilometers. The land cost, I'm just calling it land, is going to be dollars per kilometer. So at the end of this, I'll just have dollars out of it. So let's work on the length of this thing. So in other words, what's the length of RP? So the length of RP. Well, if I'm looking at a Pythagorean theorem here, I have a right triangle. I get 1 squared plus x squared. Now to get the cost for this pipe over the land, it's going to be the length, 1 plus x squared, times 500,000. Now the cost over the water is going to be the length over the water times the 800,000 per kilometer. Now this little triangle, if this length is x, and the total length, this is going to vary in your problem, is going to be 8, then the remaining length from P to here is going to be 8 minus x. So this particular rectangle is going to be PS, and that's going to be the square root of 3 squared plus 8 minus x squared. So the cost over the water is going to be the square root of 9 plus 8 minus x squared times 800,000. Now the total cost is going to be equal to the cost over the land plus the cost over the water. And this is the model for the problem. And that should help you start the problem. I hope this was useful. If you have any questions, let me know. Bye.